Morning, dear students. Today we are going to discuss the continuous topic where we left yesterday. The topic where we left yesterday. See, we are in groundwater sources as part of water sources, types of water sources. We are discussing environmental engineering 1, which is exclusively designed with respect to water from the source to destination, or is from the source to consumer. We are just discussing here from the source to the consumer. Already we explained the flowchart, the topics, what we discussed. This is the flowchart. You must learn, you must focus on this flowchart. I'm sure that you may get a question as in a short answer about this flowchart. Sure, in the sense, I'm strictly insisting you, please learn this flowchart. This is what the whole syllabus of this subject, the name of environmental engineering 1. Here, the first title, we learned water supply engineering. There, as an introduction part, we have discussed the necessity of protected water supply, objectives of protected water supply, and if water is not being treated properly, if water is not protected well, what are all the consequences which may spread in the name of water diseases, we learn. After that, we already discussed the topics like water demand, role of environmental engineer, design period, per capita demand, all we learn. Even we have learned estimation of water demand for a town, and we learned the formula for per capita demand and per capita demand capacity at various towns with respect to population we learn. Now we are here, the title sources of water. Sources of water we learned and we completed as per your curriculum, surface water, where you learn 3 subtopics by name: lake, rivers, and impounding reservoirs. You learn and we discuss what is reservoir and what are all the considerations to be taken before we are going to construct reservoir. And we have seen the objective of reservoir also. Now we are here at groundwater and we learn the comparison between this surface water and groundwater. And we also learned one particular topic, the name of groundwater, that is springs. There you learn and we discuss different types of springs like stratum spring, valley spring, overflow springs, solution channels, fault springs, so on. And of course, there are other type of springs also there, but we have learned as part of your syllabus is demanding. We are here, the next topic. If this after springs, you are observing here the wells. Wells also we discuss. What is the purpose of these wells? Or what is the purpose of this well? I mean, this well, the sense to get the water, or as to meet the requirement of water. What is the requirement of water for a human being? That is 135 liters per day. We have seen clear bifurcation of that 135 liters for various activities like cooking, drinking, bathing, so on. See here, when the discharge is, the required discharge is minimum, we may go for wells. And for individual purposes, in the same wells, we have seen 3 types of categories. One is percolation well, where the discharge requirement is minimum, or as 20 cubic meters. Maybe we have seen that. And for individual houses, we have seen driven wells. And when the requirement is more, we have discussed yesterday tube wells. In that tube well, we have seen four types of tube wells: stratum wells, cavity wells, and then perforated tube wells. And of course, we have seen strainer tube wells also. Now we are there. See here, after wells, the associated topic is infiltration galleries. See, now today we'll discuss the ABCD of this infiltration galleries. What is this infiltration gallery? The name itself revealing to us there are two words: infiltration and gallery. Gallery, you know, what is infiltration? Here, infiltration, the other word of infiltration is nothing but percolation. Percolation of what? Here, as we are dealing with water, nothing is there. Percolation of water to where? To the deeper ground. Here, infiltration galleries. That means water water will be percolated into the ground and will be stored. See, in the gallery, in the sense you may be heard and you may be observed, open galleries. There, people used to sit out there and used to watch what happening there. But here, infiltration galleries, in the sense the water get infiltrate and will be stored over there, that will be used for requirements for various activities. Now we have a look over there. When we have a look over there, see, this is the diagram of infiltration galleries where we are observing the groundwater table. This is the groundwater table and flow of groundwater. Deep holes, in the sense through these deep holes, water will enter into the gallery. See, this is what gallery, and mostly these type of structures we used to observe at the banks of the rivers, where plenty of underground water flow is available. Where we used to construct not any area, not any nearby lake, and not any nearby villages or not any nearby urban areas. These are exclusively meant to meant to construct at the banks of rivers, and not only banks of the rivers, even those selected rivers must and should have the water flow within a maximum capacity through which water flows or water enters into the galleries, which is constructed in 3 layers. You understand what I said? One more time. These galleries used to construct at the river banks. River banks, in the sense, not all the river banks. The river banks where the groundwater is available at maximum, or else plenty of groundwater is available, there only these type of infiltration galleries can be constructed to meet the purpose, or else to meet the requirement of water. See, because when the groundwater flow is, as the groundwater flow is maximum, by keeping these type of structures nearby those river banks, automatically water get infiltrated into the ground, and as we have made weeps to the galleries, through the weep holes water enters into the galleries. Now we'll see how these type of galleries used to construct and will be constructed at the banks of rivers. For that, these galleries will be normally constructed in 3 layers. In 3 layers, the first layer will be constructed 3 layers, in the sense it is 3-layer structure. Do you observing here? This is 3-layer structure. The first layer is made up of with a thickness of 16 centimeters by using, or else by adopting, the material like ballast within a size of 25 mm to 50 mm size. Followed by the next wall is followed by the wall is constructed with pebbles, small stones, pebbles with a size of 12 mm to 24 mm at a thickness of 16 centimeters as an intermediate layer. After this intermediate layer, the wall will be constructed by using fine pebbles with the size whose size is around 3 mm to 10 mm size at a thickness of 24 centimeters. Like this wall will be constructed in three layers: primary layer, or as outer layer, intermediate layers, and inner layer. The outer wall, else the first layer is made up of with a 25 mm to 50 mm size of ballast materials at an average thickness of 16 centimeters, whereas the followed line or as followed wall is made up of with pebbles whose size is 12 mm to 24 mm at a thickness of approximately 16 centimeters, and the last inner layer is fine pebbles of 3 mm to 10 mm size of thickness within a say within a I mean within a 3 mm to 10 mm size of material thickness, and the whole wall thickness will be 24 centimeters, which will be an outer layer. Understand? Then by constructing the galleries like this, we used to maintain weep holes. Through these weep holes, nothing but blank holes. Through these weep holes, as the water flow is plenty nearby river banks, slowly water get percolate or infiltrate into the galleries. From there, from here, on the pipeline will be arranged. Through that pipeline, the water will be distributed to meet the requirement. This is what about infiltration galleries. Infiltration galleries, in the sense, what is getting infiltrated here? Water is getting infiltrated to what? To where? To the galleries. Galleries, in the sense, we made up in three layers, and we have seen the specifications. From the galleries, the pipeline will be arranged. The pipeline will be fixed. Through the pipelines, the water will be supplied to meet the requirements as per the as per the requirement. Here, see, that means in the groundwater sources, we have seen the first one springs, second one wells, third one infiltration galleries. These three comes under groundwater source, whereas we have seen as part of surface water, we have seen lakes, rivers, reservoirs, and all. That means here for groundwater we have seen three subtopics. For surface water we have seen three subtopics. Now we are entering into the next topic, intakes. Keep in mind, we are discussing about water supply engineering from the source to consumer. Slowly we are entering into the topic. In the previous case, we have seen the source. Once we found the source, from the source, the next topic is how can we collect the water from the source. The only way to collect the water, or else the process of collecting water from the sources, will be with the help of intakes. What is this intake? How can you define this intake? We'll discuss now. These are the structures constructed. These are the structures constructed to withdraw the water from the water bodies like rivers, canals, etc. So far we have seen the source, and now we are discussing about the structures of what? This is not the structure of 3 stories or 2 stories building. This is the structure which is constructed to get the water from the source, and from there the water will be supplied to the consumer after necessary treatment. That is what we are going to discuss in the name of intakes. Here, intakes, when we have clearly observed this word, when we are trying to divide this word as in and takes, in the same takes, here nothing, we are just collecting insights. Intakes, here the main objective of this intake is to supply the water for public consumption after the treatment. Now, what are all the different considerations to be taken to construct these intakes? Keep in mind, see, we have seen these type of considerations for water demand, for design period, and even for reservoirs. We have seen what are the factors to be considered when we are going to construct these type of intakes. First and foremost thing is working process. The intake structure must be designed by keeping in mind that should work 24 hours, that should work 365 days in a year. We are not supposed to give any, we are not supposed to keep those structures without working. See, that means what I'm stressing and what I'm focusing is here, the structure must be designed in such a way it should work continuously in an operation mode. Yeah, see, if the intakes are not working, it clearly indicating us there is no supply of water. If the water is not being supplied to the public, you are not a good engineer. That means you must monitor these intakes continuously, and this is the prime, that is your prime responsibility to make those intakes working continuously. Then only water will be supplied to the consumers. So the first topic and first point you should keep in mind before you are constructing these intakes is working process, else the efficiency of working. Next one is strength of the structure. See, normally these intakes used to construct at the banks of the rivers, lakes, or canals. If you are not constructed this structure in such a way to withhold or as to withstand the currents of waves or as to withstand the forces from the waves, the structure will get collapsed and the water supply will be stopped. That is the reason the structure what you are planning must withhold the strength, withhold the forces of water as you are constructing the structure nearby river banks. The first one is you must monitor the structure in such a way it should work continuously. Next one, it should withstand the forces of waves, and the structure must withstand the forces of the water as we used to construct these intakes nearby river banks. What is the purpose of this river bank? To collect the water. And where you can construct? Obviously at river banks. You are not supposed to construct these intakes any side by highways or side by bridges somewhere else. You are going to construct these intakes at river banks as the main purpose is to collect the water, right? And third one is water quality. Keep in mind, we are discussing about the consideration to be taken for constructing intakes. The first one is working process. Second one is strength of the structure. Third one is water quality. The quality is here, the selected site must be free from all the possible human activity. See, I said that you are going to construct these intakes at river banks, and regularly we used to observe at the banks of rivers and lakes there will be a possibility of human contamination more and more. Contamination of water due to human activities. You must select the site where the human activity is less or else absence. Then only you'll get the good quality of water through the structure. Understand? See, what I'm stressing is here, normally we used to observe at river banks and at the banks of canals, if the water will get contaminated because of the human activities, maybe washing clothes, maybe swimming, maybe something else. The site must be free from human involvement so that the quality of water will be good. I said that it should be away from the human involvement. It doesn't mean that you can construct somewhere else to collect the water by maintaining a pipeline so that as the structure is far away to the bank, I can collect the water by maintaining pipeline something else. For keeping pipelines to collect the water, it is in a cost effective. As an engineer, you must remember that must be economical, and that must be the cost benefit to the consumer. If you are maintaining pipelines to collect the water, and after collection there is another process. After the process, the cost of the water will be high when you are investing much amount of money for collecting by keeping pipelines. Understand? I said that particular structure must be away to human activities. It doesn't mean that you can construct the intake away to the banks. You may think that by keeping pipelines, I can collect the water. For keeping pipelines, you must invest the money. If you are investing money, the source to get your investment is obviously consumer. If you are imposing high amount of money for supplying water, it is not an economical, it is not an user friendly. That is the reason the structure must be at river banks, but we must be in a thought, we must be in a position to select the site where the human activities are minimum or less. The next one is economy of construction. See, it is the most important factor to be considered. Just now I said that in a classic example. See, it is the most important factor to be considered, and all the guidelines must be followed. And with respect to the treatment and with respect to the budget and all. See, your economy of construction. The economy of construction must be feasible, or it must be in such a way within the budget. See, at the time of proposing structure, construction, the budget is pre-allocated thing. Your treatment process and your pipeline selection and everything must be within the budget. Then only you can give the, or then only the water will be supplied without any obstacle. That is what the economy of construction must be within the budget, and the other parameter to be considered before the construction of intake is nothing but future scope. Whatever the structure you are going to construct, you must be in a thought, you must be in your plan. There should be there should be a feasibility for future expansion. That is the reason we used to hear some certain plants or certain industries, plant 1, plant 2, plant 3, something like that. That means the site must be feasible to expand your future projects also. Understand? See what all the consideration we have observed from the first. We'll see one more time. First one is working process. The second one is strength of the structure. Third one is water quality. In the fourth one is economy of construction, and the last one is future scope. All these factors must be considered before you are going to construct these intakes. The next topic is types of intakes. Right. Somehow you selected the site, and somehow you construct you're going to construct the intakes. Now, what is the type of intakes you are supposed to select? There are different types of intakes. The first, and they are as follows: canal intakes, reservoir intakes, river intakes, and lake intakes. In this topic, or as part of the topic intake, we will discuss all these intakes one after one. Right? Understand? Now, did you understand what is intake? These are the structures these are the structures meant to collect the water from the sources. We have seen the sources. Now we are trying to collect the water. How can we collect? Through intakes. What are the factors? We discuss. Now we'll discuss first type of intake, that is canal intake. The name itself revealing to us canal. You know what is canal? Here at the center, see how can you construct this canal intakes. See, have a look over this particular diagram. This is about the canal intakes. See here, see water levels you are observing here. This is the wall, and this is the brick chamber which is constructed at canal bank. See here, the water flow is like this, and you must be constructed this brick chamber at the banks of canals like this, so that like this, in the sense, by keeping the collecting pipe at downwards, that is at the bottom of the brick chamber, so that water will be collected at all the levels of canal. Understand? This is the brick chamber which we used to construct the banks of canals, and through this brick chamber, see, one geyser is there, one screener is there. It just making just stopping all the entry of unwanted particles that used to float along with water. This screener will act as a guard to avoid the entry of all floated materials. The water through the screener enters into the brick chamber. Here in the brick chamber, at the bottom, we just used to keep the pipeline like this. Even that pipeline used to have one screener. See, there are two screeners. One is maintaining at pipe, and the other one can be keep at the entry itself. By keeping the screens like this, we can avoid the entry of unwanted particles, or even we can avoid the entry of small fine particles into the pipeline. Through this pipeline, as it is connected, or as it is acting as an outlet, this outlet will be connected to the treatment plant. From the treatment plant, after the treatment, water will be supplied to the consumer. Understand? See here, at the center of brick chamber, a bell mouth opening is fitted, which is extended to the other side of the canal bank as outlet. Now the condition is satisfied. See here, at the center of brick chamber, a bell mouth opening. This is the bell mouth opening is used to kept, which is extended to the other side of canal as an outlet. This is the outlet. The opening is covered with screen to avoid the entry of fine particles. The flow is controlled by a wall fitted at the top. of the brick masonry chamber. The water from the outlet will be sent to the distribution system after the treatment. This is what about the canal intake. You must learn the diagram. What is we must learn the diagrams like canal intakes and whatever the whatever the type of intake you must represent in exam with diagrams. Keep in mind everywhere almost this even everywhere used to encounter diagrams. So keep in mind you must thorough enough about these diagrams, then only your paper will get evaluated in such a way will get the good marks. See here today we have discussed about intakes and also the factors considering to be factors to be considered for constructing intakes, and also we started the first intake canal intake. If you have any doubts, please contact me in the way whatever you feel convenient. Thank you. Tomorrow we'll continue the other type of intakes.